Hey everyone, Ryan Boyd here. I'm a co-founder at MotherDuck, and I'm quacking excited to be speaking at AI by the Bay, taking place in Oakland, California from November 17th through 19th. I'll be speaking on analytics data infrastructure for AI. LLMs are super magical, but they're bad at facts, and especially bad at aggregating data facts within a business. I'll talk about the infrastructure needed to make LLMs work alongside analytics database engines, and the hyper-tenancy architecture we built at MotherDuck with DuckDB to make it easier, more efficient, and less risky to have your LLMs interacting with your data warehouse.
Hello, everybody. I'm Alexey Krabrov, the founder and co-organizer of AI by the Bay, the longest-running, deepest technical, independent, still standing community open source AI conference in the Bay Area, running for 11th year in beautiful Oakland, California. We call it Oakland Riviera on the shores of Lake Merritt in the Oakland Scottish Rite Center. And we're thrilled to have Ryan Boyd, founder of MotherDuck, with us. And it's a major supporter of the conference. And DuckDB is one of the most fun things which happened to computers in the recent memory. So I'm kind of joking to people, there are two things happening in computers. It's AI and DuckDB. And anybody who goes to any kind of events with DuckDB can feel the vibe. And the small data conference last year was super fun, and small data conference SF is coming up again, right? November 4th to 5th. I need to go there. So, Ryan, question, why DuckDB? Why is it so much fun? Why developers, why do they love it?
So I think, well, first of all, I'm slightly embarrassed here on behalf of Hannes and Mark, who are the creators of DuckDB. I think what they've created is magical because of its efficiency and its focus on ease of use, developer experience, whatever you want to call it, right? We have spent the last 2 decades building infrastructure for building infrastructure's sake, and not really focusing on, is it the right size of infrastructure for our data problems? People like myself, back when I worked on Google BigQuery a decade ago, oversold on everyone on you need this huge infrastructure. It's just not true. You don't need a huge infrastructure for the vast majority of use cases. And it comes at a cost to build that huge infrastructure. It comes at a cost of maintaining it. It comes at a cost of the complexity and debugging it, going through those Java stack traces with Python in between, as I'm sure every person using Spark is familiar with. So, DuckDB was created really just to say, let's get something super lightweight, super efficient, focus on what people really care about when working with data. And, that's everything from are your queries fast to is the SQL that you're writing understandable and the SQL that you're writing easy to use? And, it started off as this embedded database that everyone is just like, okay, that's just for small scale applications or what have you. We have this conference, small data SF. The reality is people are doing huge things with DuckDB, just many DuckDBs. And, at MotherDuck, we call that scaling hyper-tenancy. But the reality is that vast majority of use cases can work with a simple database engine like DuckDB. And I'm just really happy to be working on it because of the name. It's all about the name, man. It's all about the name. And I get to have ducks, cute ducks, which you can kind of see peeking from behind me. And, let's just make data fun again. And that is the name is part of that, but also just the simplicity, ease of use, the efficiency, the reduction in costs that you get by using something like DuckDB.
I want to give credit to Hannes as well. I've just seen him talk keynote PyData Amsterdam, right? In his hometown of the institute, which gave birth to Python and DuckDB. I really like how you guys destroy legacy architecture. So it's last year, small data, you presented basically the talk that big data is dead. It was a bunch of it's a matrix, right? A matrix of distributed computers. They'll go away. There is one big beefy computer running one big beefy DuckDB supplanting it. And so Hannes showed the client server architecture from 90s and 80s, right? It's there is this master server in the cloud and a bunch of leaves, and this is all now gone again. There is a DuckDB instead of all of that. So Why do you guys like to tear down all these legacy architectures, and what's coming instead? And the tricky question isn't MotherDuck in the cloud another kind of this? Now you hadn't processed database, and now you put them all back in the cloud. So how does that work? Walk us through it.
Have you ever played with Legos when you were a kid?
I brought up in Soviet Union. I had wooden branches, and
you build them up, then you tear them down, and then you build them up again. I mean, our industry works in cycles, right? And the thing is that there's plenty of interdependencies here. The quote unquote big data architecture where a single query would get distributed across thousands of nodes was needed back when I worked on Google BigQuery for a lot of use cases. The thing is that compute has advanced, processors have advanced, memory has advanced, disk read write speeds and other IO have advanced. And that creates different opportunities on the software side to simplify things. If you looked at, I think one of my queries that I demonstrated with Google BigQuery that took some odd seconds on 1,100 machines back a decade ago now runs on my laptop in, I think it's 50 seconds or something in DuckDB the last I tried it. So a little over double the time, sure. But it's on my laptop instead of 1,100 different machines, right? I think, with MotherDuck, we are trying to recognize that compute is changing, the processors are changing, memory is changing, all of these other dependent systems are changing, and how do we change along with it? So we, take advantage of the idea that DuckDB can run in the browser and on your laptop and do something what we call dual execution, and it really, that's one of those areas where I'm trying to focus less on the technology itself and more on what that enables. So what that enables is if you go through the MotherDuck web application and you type a query, we can automatically preview the results of that query in milliseconds without going up to the server, because it's able to process that locally in the same DuckDB engine as it would process in the cloud. So we really do believe in sort of joining the capabilities of your local machine with the capabilities in the cloud and just keeping it as simple as possible for users and for debugging and for, frankly, the infrastructure for us to maintain too. A big part of that is just saying, a query doesn't need to be processed by more than one machine in the vast majority of cases. You still need to be able to run tons of queries simultaneously, and you want to be able to scale that. And, for that, things like our Hyper-Tenancy architecture, where individual customers get their own dedicated, your customers get their own dedicated DuckDB instance, for example, or every user of an internal data warehouse gets their own DuckDB instance that can scale up or scale down. But there's things like that which enable us to still scale out at tremendous scale without the complexity of being able to distribute each individual query across that many machines.
Well, that's great. So that's kind of innovative architecture, local first and cloud. So I want to kind of double click a little bit on this theme of extreme efficiency and ruthless kind of software engineering. So Hannes again talked about it at PyData Amsterdam, and I think that also was in small data conferences, that they engineer DuckDB to be extremely efficient. So I think his example was you throw a giant data set on it, and it doesn't die. It slowly but surely chugs through it, right? It doesn't blow up on joins. And so there's a lot of work still ongoing at DuckDB, right, which is the research. So how much did that contribute to the success of DuckDB, that it's very resource efficient, can operate in a very constrained environment, on old machines, suddenly can be database servers? How much did it contribute to the success of DuckDB?
It's a really, really interesting question. I think that that caused the origination of DuckDB. So in that way, DuckDB wouldn't be here if it wasn't for that. Hannes and Mark saw their colleagues who were scientists working at universities using things like, the SASs and SPSSs of the world are using things like data frames and not using a real database, as they call it. And, they created DuckDB for them. They created DuckDB to give those researchers a real database. And it did start off as just this lightweight local library running inside R, at the time, and then into Python. It's now the more popular. So that's the origin story of DuckDB. So in that way, it's super critical. In terms of kind of its wider adoption, it runs in Lambda functions. Last year at Small Data SF, we had the folks from Okta talking about how they run thousands and thousands of simultaneous DuckDB engines in Lambda functions to transform their data. And, Lambda has pretty strict requirements from a resourcing perspective, so it enables things like that. For us, really what we saw in it is that innovation. I mean, you pick a technology for your data infrastructure based not only on where that technology is today, but where you think that technology is going to go. And as startup founders, even more so, right? We're picking who are going to be our partners in this world for the decades to come. DuckDB was that for us because we saw the innovation with the ruthless focus on efficiency. We saw that an academic paper would come out at a conference, and a week or two later, they would have the results of that academic paper implemented in DuckDB. So new compression algorithms, for instance. Some random researcher around the world would publish it, and the DuckDB folks would be like, sweet, this will make this faster. And they pick it up and implement it and launch it. And that is amazing for us. Sometimes their innovation is so fast that it keeps us on our toes because we then need to deploy it to our customers. That's why we're aligned with these folks, and that's why our customers are aligned with us, because they believe this is the direction for the future of data analytics.
I was just checking that MotherDuck was founded in 2022 in May, and that means that it's a little bit prior to the big breakthrough with ChatGPT popularity and adoption. I mean, people in the AI would know before ChatGPT 3 that something big is happening, but for broader audience, that's when it happened. So I assume, like you said, when you're startup, you need to see what's ahead of you in a very long run to be successful. Yeah. I think that the landscape changed quite a bit after this breakthrough. So I wanted to hear how that changed the strategy for MotherDuck. So anticipated one before that, and what happened actually.
The VC landscape and the financing landscape. And we were just very fortunate to have a lot of investors early on take really big bets on us and give us the runway that we needed to build MotherDuck as a service. Building data infrastructure takes a lot of time, takes a lot of focus. Nowadays the VC market is completely different. I have no idea what it would take to launch a company like MotherDuck in the current VC environment, because they're looking for these these bets, and there's some of these companies that are going from $0 in revenue to like $100 million in revenue in 9 months and shit like that. So sorry, not to swear at you, but like there's some craziness going on in the AI world as it intersects the business world and VC financing world. So in that way, I think we were lucky that we started before the AI wave. How does it affect us? I think actually it only helps us. And why I say that is because, data is at the heart of all AI. There is no AI without data. There needs to be infrastructure to store data, and AI needs access to that data in order to train and in order to execute. I think what happened with the LLMs is it gave a renewed focus on data throughout the industries that we work with every day as customers, as prospects. It gave a renewed focus on them thinking, Data is important for us to be successful as a company. And, some things like the, small language models give the idea that, well, data is important, but high quality data is even more important because it allows you to build much more efficient models that take a lot less compute to train and to execute. And so, I think it's only been benefited us. It has changed some of the conversation. I think, in the first week, actually, that we kicked off MotherDuck in Seattle at the Madrona headquarters. That was in June of 2022, where we all physically got together as the co-founding team. I think in that first week, we talked about, the text to SQL. And at that point, there were a number of naysayers in the room, people that had spent a decade trying to make text to SQL work, and it didn't really work using kind of traditional AI models. And now we're seeing changes there on the, we're still not at the point where text to SQL really works, but we're seeing a lot of advancements that, with the right schema and understanding of that schema, with the right metadata around your data, we're starting to be able to take human language and convert it into results. There's still a lot of things there, like ARR means different things to different companies and different people within different companies, like a lot of definitional challenges. But it does create a whole new wave there where, the ways that you're interacting with your data can change. And that's exciting to see. And, that includes LLMs. We have customers who basically have LLMs answering questions using MotherDuck as their data source and just generating tons and tons of SQL queries to find out their answers. Consumption-based business, those are very good customers for us from that standpoint. But also it's building a better understanding of the data. And if you can make the machine understand the data better, and that helps the people understand the data better, that's what we're looking for in business. So
this is great. I want to shift gears a little bit and talk about DevRel, right? Because small world. I'm now at Neo4j, the wonderful database company in the DevRel team, and I found that Ryan was there before me and left amazing legacy and educational materials and everything. And
it's a broken bit.
And our by the way, meetups, we actually. SF Scala was where Matei Zacharia launched Spark. For the first time, we spun off Beta Spark meetup as the very first meetup in the world. Asked Matei actually to start it, right, many years ago. And so then, Ryan, you were DevRel and Databricks, right? And so what really amazes me, I've been to hundreds of meetups, seen a bunch of companies. I really like the DevRel strategy of MotherDuck. I think that's the most fun, it's the most exciting. So I just wonder, how much is it nurture versus nature? Obviously, DuckDB is an exciting product, but you guys are throwing the funniest, most fun parties, the side shows on the vendor events. People come with their vendor badges to see DuckDB dancers, and get free old fashions of very high quality, which I highly recommend of partaking. So how did you come up with this? Is it decades of experience in DevRel? What really works? To attract developers? Is it the magic? Tell us, how do you make this all happen?
First of all, the question is it DevRel or is it marketing? Or does anyone care? I'll give you a bit of a secret here is when Jordan, first asked me to join him on this adventure of starting a company together. This is Jordan, as our CEO. I used to work with him at Google BigQuery. He was like, "Oh, okay, so you wanna run DevRel? Great. So here's and I'm like, actually, nope. I want to run marketing. And DevRel is part of that, sure. But I want to run marketing, and it is my first role actually running marketing officially. If you ask the folks at Neo4j or some other places, I've been a rebel marketer in the past. People have regretted handing me the keys to Marketo or to Salesforce, when they went away on vacation and I got myself in trouble. But in the end, they were very thankful for it. And I think really what we're trying to do with marketing at MotherDuck is take true empathy for the audience that we're trying to reach. We have this audience of data engineers and data analysts and data scientists and AI folks and software engineers, product managers. This audience has a diverse set of skills, diverse set of interests, and, different reasons for living and why they go to work every day, what they're trying to do to advance their careers. I think a lot of other companies tend to forget that and tend to kind of focus on the lowest common denominator or, other cheat codes per se to make it easier. We try to take that, empathy for that audience to heart and say, what would these people want, right? And they don't want another company with a black or blue logo. They don't want another company just pitching at them. They want to have fun. They want to enjoy their jobs. They want to learn new technologies and use those technologies to advance their careers. That's really the approach that we take, is we're just going to be like, we're going to make this world not boring again. And that sometimes means putting the duck suit on. That sometimes means having like really fun swag and fun parties. And then combine that obviously with great technical resources, a great product behind it, et cetera. But yeah, it's really about bringing the fun back to data.
And thank you for doing that. I really enjoy all these parties and, can't wait to go to more of those.
So I am a little bit of scientist myself, so it's always an enjoyment for me to go to MotherDuck website because I know that everything is styled with ducks and this is fun. But actually, one thing that everyone knows about parties actually and duck swag and everything, but I really love this DuckDB Snippets website, a little separate website where you can either create your snippet and share. That's like a little few lines of code that you share with the world or exchange, and which does something like, for example, I opened one right now and it says like quickly convert a CSV to Parquet a bash function. So everyone can go and copy this bash and just run them. So I think this is given back to community. I really love that.
So MotherDuck is a commercial product. MotherDuck is not open source itself. But, we do really believe in the open source ecosystem. We have this very unique business model where we went to Hannes and Mark and said, hey, we're trying to build this business. We know it is based off of your open source technology. We don't want you to feel like we're abusing that open source. We want to be good stewards of the community. So they have a founding share of MotherDuck, and we just kind of gave it to them because we are using their technology. And then we also have a contracting relationship where we pay them, to help implement features which help MotherDuck scale and things like that. But those features all go back to the open source world, right? So yes, we don't write open source code, but we spend plenty of money from our bank account to support the writing of open source code. And, things like the DuckDB Snippets site, it was actually originally inspired by we actually took the thank you off because the website that it was inspired by went under, but I think it was bash snippets or something, the .com originally. And it's just like, give me like short little things that let me get my job done. Nowadays, maybe some of the AI tools, Claude might give a lot of these answers, but it needs to find it somewhere. So hopefully, DuckDB
that's where
the place it finds it. Yeah. So, but yeah, we do like to give back. The DuckDB UI. So if you type DuckDB --UI, that's built. We're slowly open sourcing some of those components to make that available. But, meanwhile, the tool is there for everyone to use, regardless of whether you're using our commercial product or not. We also do have a free forever plan within MotherDuck. That is part of our ethos is really just help the community of data practitioners. Then they'll come to us when they're ready to come to us. Not everyone needs a new data warehouse every minute or every hour or every day or every year. But, within that 7-year time frame that most data warehouses last, hopefully folks come and look at us based off of our participation in the community.
That's great. I want to ask, about this feature, which really struck me as completely innovative. Like SQL is a, 40-plus-year-old language. The second query language standardized by ISO is GQL, which is Neo4j's cipher. It took 40 years to do something like this. And you guys came up with this instant SQL, right, feature. So you type SQL and it brings up results. Is it like the millennial kind of Zoomer kind of thing, like you want immediate things showing up, you want completion? How did you guys come up with this? It's real innovation in SQL world. Is it MotherDuck? Is it DuckDB? Is it a collaboration? Like, did customers ask for it? How did it come about?
It really, I think the background is in Hamilton, the engineer on our team that created it, who now leads our UI team. Hamilton has background as a music producer. He has a Grammy on his name as a music producer. With that, like he looked at all the, music production environment. What does he need to produce great music? And he calls it his flow state. He needs to just be kind of attached to the music. And I don't know the exact language that he uses to describe it, but there can't be the delay because otherwise you get broken out of that flow. So how do you stay in constant movement, constant iteration on your music? The tools enable that. And so he took the ideas from a lot of the music synthesizer world and said, how do we bring that to data? And so it really came from him. And before, it probably just wouldn't have been possible without this sort of dual execution world where a powerful SQL engine can run on your computer that's the same SQL engine is running in the server side. So, essentially what it's doing is pre-caching and such, which has always been doable. But if you're pre-caching data using a completely different SQL syntax locally as remotely, that just makes this a very difficult invention. The dual execution made it a lot easier for Hamilton to write this. We hope to continue to expand that and get everyone into their flow state.
This is amazing. Can we get Hamilton to DJ at AI by the Bay? Is he available?
I don't know if he still does that. We had Joe Reese DJ at our Big Data London party. So Joe Reese, the author of the data engineering.
That's right.
And I think he had Carly Taylor with him and some other folks with him helping. There is a lot of music people in the data world, but I don't know if Hamilton will do live DJing. I can certainly ask.
And maybe for the backs, ground, we can build some real-time SQL animations. Just an idea.
Oh, we have a fun thing that we're playing with. We're very into the booth experience and the live experience, and how do you merge the physical world that we're all in with databases and data. And so there's some fun things that we're playing with there. But in the meantime, have you seen the Duckify app, Duckify.ai?
Not yet.
Go take a look at Duckify.ai, Duckify.ai. This is another way we're trying to bring some fun to data. You could take any picture there and Duckify it. So I already took a screenshot of us talking, and maybe you can use this as your Duckified version of this as one of your social images. But so, we actually did that live at Big Data London at our booth and printed photos out for people. And we're doing other things that kind of merge Duck world and the real life.
Nice. That's really good. Let's Duckify it.
Let's Duckify it. That's what we're trying to do with the world. Go get the duck and Duckify it. And the duck solves all problems. That is actually, the developer experience focus of the DuckDB team is a huge part of what I think makes DuckDB a winning technology. And that they're not about strict conformity. You'll notice that they've expanded the set of what SQL can do just to make it a little bit easier, because it shouldn't always be about this standard that is 20, 40, whatever years old, right? It should be about what allows people to get their job done. And, that's what they do. And then they take that to things like CSV import. The amount of time and energy they've put into CSV import is probably more than anyone else on the planet. That is where, how do you deal with there's one record amongst thousands that is off? How do you handle that? Or someone threw a very weird delimiter in. Can you detect that? Or, all sorts of things with regards to CSV or JSON or other imports and exports. And so I don't know, maybe we'll have SQL results duckified eventually.
That's awesome. So I want to give out, a secret. Like, I know we're all bound by an oath as professionals, but if I have your permission, I want to give out a secret into the world. Like a while ago, I figured out what a data lake is, and you can tell me if it's true or not. So I found out by random accident this big secret, right? That a data lake is just a bunch of CSV files in an S3 bucket. Is that true?
It fits my definition of data lake. Data lake is a central repository of data, accessible usually via HTTP of some sort, which is like the S3 protocol. If it's CSV, that's fine. If it's Parquet, that's fine. If it's Iceberg or Duck Lake or, Hootie or other things, like that's fine. Most of those are just layers on top of Parquet anyway. I don't think it matters what the format of the data is. What matters is how understandable is that data, how like the catalog, how do you get access to the catalog? What is the information that is out there? And, then and how much of a mess is all of that, right? So we went through the era of let's throw everything into the data lake, and then, the whole data swamp world came out. And that's because people threw it in a bunch of unorganized ways into an S3 bucket, and then they called that their data lake. Now, a clean data lake has things better organized, and a really clean data lake has a really great catalog on top of it and transactional support on top of it. And then at some point you call that a lakehouse because it can, serve as the same, serve the same functionality as a data warehouse. Although I would argue that a lot of lakehouses nowadays, can serve at high scale the same capabilities of a warehouse, but there is increased latency versus many warehouses. That is one of the things that we're doing differently at MotherDuck is we're look for sub-second latencies, sub even, a couple hundred milliseconds latencies on a lot of queries, which allows serving different types of analytics applications than what a traditional data warehouse would do well when there's an end user sitting and waiting for the result. But lakehouses kind of take it the other direction, although you're seeing there was actually a DuckDB extension released, I think today or yesterday, by someone in the community that puts heavy caching in front of a lakehouse type approach in order to, give faster latencies with DuckDB. But yeah, so that, yes, data lake is just a collection of data in some bucket somewhere. And then, the utility comes on top of that.
Yes. So this reminds me, I started as a joke, but then, every joke is a fraction of a joke. I remember another piece of Hannes' talk at PyData Amsterdam, where he talked about Duck Lake. And I didn't go deep into this, but I think what he showed was, so here's how we do go about, building a data lake. You would basically have a bunch of tables, and then you have a bunch of metadata. And if you run out of one, you add another one. And so there is now a bunch of files. But then if you delete data, then you add a bunch of other metadata, which basically tombstones the previous data. And then you can have a bunch of metadata showing what's actual current set of metadata governing the bunch of original files, which have Parquet files in buckets, right? So that basically becomes Iceberg. And then, this is the part I didn't really get. He showed a beautiful, almost empty screen with like only two things in it. Yes, and this is the Duck Lake, which is much simpler, but I didn't get how is it simpler. Is there a better way to do this in this Duck Lake, that thing? What's the simplification?
The simplification is a questioning of assumptions. So Iceberg had this assumption that as they were designing it, that the data as well as the metadata should all be accessible over the wire without a server per se, right? With just using this blob storage that's out there. So we've had the separation of compute and storage. The idea is you should just be able to use that storage engine and access all of your data. No traditional database involved here. We've seen a resurgence of the popularity of Postgres in particular as a transactional database in our industry. And pretty much every single company is going to run at least one transactional database for their company. And usually that is Postgres. So what Duck Lake said is like, okay, there's all this overhead of interacting with these metadata files and layers on top of layers on top of layers of metadata files that you have to interact with in order to make a query from like an Iceberg data lake or Iceberg powered data lake, or even a Delta powered data lake. It doesn't matter. All of these have this assumption that you have these metadata layers, whether they're Avro files or JSON files, you have these metadata layers. And so that can result in like 80 HTTP requests to, do a simple update. It's just inefficient. And it's inefficient by design because they didn't want a traditional database, involved. And so what Duck Lake does, it just questions that assumption and says, hey, everyone's using Postgres anyway. Everyone's using a transactional database anyway. Why don't we store all that metadata in a transactional database and, have, I don't know, 20, 50 millisecond queries of all of our metadata, a single SQL query being able to return the results of the metadata instead of 80 HTTP requests. It really is just about like that questioning of the assumptions. It builds upon the same innovations that the Iceberg folks did, that the Delta folks did, the idea that, we can have a transactional database that is hosted in, a blob store like S3. It builds upon that and then just says, well, let's just simplify that a bit more. Very similar to what like they did with DuckDB in terms of paring things down and simplifying it. So that's why I'm excited about Duck Lake is just it makes things easier. Some people question but this is just for DuckDB. It's an open standard. I think actually Duck in the name confuses people a lot. The initial implementations, it was created by the same people that created DuckDB. The reference implementation is with DuckDB and with Postgres, but you can use any database you want on both sides, right? Like with whether, any database for the compute of the data and any database for the transactional database that stores the metadata. It's really about being an open standard and making it not only easier on the consumers, but also a lot easier on the people implementing it. I think that, Duck Lake really came about because Hannes and Mark, were trying to implement write support for Iceberg within DuckDB. And, they're realizing how challenging it is to write another database in order to implement write support for Iceberg in DuckDB. And so they're still devoted to doing that or dedicated to doing that. And they actually improved in the latest release a lot of the Iceberg support, added write capability. But then they said, hey, let's just simplify things a little bit for the future.
That makes a lot of sense. Thank you for explaining this. Now I got it. If it's all a bunch of metadata, that's probably reasonably sized. You can just shove it into a SQL database and it's structured already and just run SQL queries over it.
It's like 1/100,000th the size or something on average. I mean, it's a tiny percentage. And so some people are like, well, but the relational database won't scale. Again, compute has changed a lot in the last 10, 20 years. You can easily have petabyte scale, data lakes backed by metadata that is, much tinier than that in a Postgres database.
Makes a lot of sense. Really, thank you for explaining that. That's pretty much all I had. Ollie?
Yeah, let's wrap up this episode. Thank you, Ryan, for coming, and we hope to Duckify by the Bay in November.
All right.
Duckify the world. Go get the duck, everyone. Go get the duck. Thanks.
Yeah.
Thank you very much. See you soon in November. By the Bay.